right, so everybody can see my screen, hear me? Just had my first technical difficulty there earlier today.
Yeah.
All right, perfect. Thank you. All right, well, here we go. Again, same idea as what we've been doing. Only we're going to do something, a new topic, but the way we're going to do it is the same. But our formulas are going to get a little more complicated, just a little more variables and stuff. And so again, we're dealing with prisms here again. Which means that you can cut them, all their cross sections would be equal. And we're going to look at surface area, which is the amount of material needed to cover the outside of an object. In essence, it's like wrapping a present, all right? So it's like how much wrapping paper would you need to wrap certain objects? So here's our old prisms that we were looking at before, our rectangular prism here. Again, looking at the variables, we have a W, which is our width, our height, and our length. So we need those three variables, but the formula, again, a little more involved. We're going to, again, always following Bedmas. Then we have our triangular prism, where, again, we have our base, our height, going straight up, and our length, right? And then I have these two variables here, S and W, and they are just the lengths of the sides of the triangular prism. All right, so that's something to look out for. All right, so here we go. Determine the surface area of the box below. Well, I got my formula just up above. All right, it's right here. And so again, we need our width, our length, and our height. So I'm going to label them. That's something I always do because especially when this type of formula, when you got tons of variables going on, it's easy to get mixed up. All right, so there we go. So I've got them labeled. I got my width, my length, and my height labeled. I'm going to substitute in to my formula here. So surface area is equal to, let me see, we got 2. And then I always like to do square brackets because I have things multiplied inside them. So I have a W times an H. So I'm going to have a 4. Again, I'm just looking at my diagram here, times an H, which is 6. All right, then we got plus. And what else we got here? Length times the width. So I got a 12 times 4. All right, plus the next one, which is length times height. So I'm going to have a 12 times 6. All right, and square bracket. All right, so now I got to follow Bedmas, right? And so I got to, inside the bracket, square brackets, I got other brackets where I got to figure some stuff out. And so what's going to happen here is the last thing I'm going to do is multiply by 2. All right, so I'm going to figure out what's going on inside the bracket. So inside brackets, I got to follow Bedmas, which is multiplying. So I get 4 times 6 is 24. 12 times 4 is 48. Whoops. Plus 48. All right, and then 6 times 12. Get the calculator for that one. And I get 72. All right, still not done with those brackets. Again, following Bedmas. Equals. So then I got a 2. I multiply or I add those together. 24 plus 48 plus 72. And I get 144. And then finally, the last step, because Bedmas, I've completed everything in the brackets, and then I multiply, and I'm going to get 288. My units are centimeters. Now, here's something that messes people up. I'm talking about surface area, the wrapping paper. As many of you know, especially if you're like me and you're not very good at wrapping presents, I have to lay the wrapping paper on the floor, and it's flat. And there's where I can see how many squares it would take to cover this object. All right, so your units in surface area are squares, because when you do put that wrapping paper flat on the floor, you can count how many squares they are. And squares are 2-dimensional. And that's, again, why we have centimeters squared. All right, next up, here we go, triangular prisms. All right, so again, I got my formula. I can't see it here, so I'm going to write it out. It's a big one. All right, so lots of variables. That's the tricky part of this formula. Lots of variables to look at. So we got base times height, plus an L times an S. So I'm going to use my diagram to see which ones those are. All right, plus an L times a Z. plus an L times a Z. Guess I better know my L's. All right, so I look up at my diagram, right, that's on my formula sheet, and I line up the different variables. Okay, and so I need my base, right? My formula, well, there's my base right there. It's 8. I need my height. There it is, straight up. So that's my height is the 3. L, the length. Well, that's along the side here. So there's my L. And, oops, I think I messed this up. This should be a B here. LB in the formula. There we go. And then I have W, WZ, and whoops. Let's see, go back up and look. Oh, I get to fix this. This should be a Z. Hold on, I just hold on here. All right, let's start over again here. Scratch this out. Okay, so we got our surface area. Copied my formula down wrong. There's a problem, isn't it? Base times height plus L times S plus L times, here, let's go up here and look. L times W plus, got to get this right, L times B. There we go. All right. So what do I got here? B and H, I got them. B, there's my H. There's my L. Now I need a W and my S. Well, one of these is W and one of these is S. It doesn't matter because they're just the other side. So I'm going to say, here's my W and here's my S. All right, so I've labeled everything. All right, so now I'm going to plug into my formula here. Surface area, got to make sure I substitute in, right? Base times height, my base is 8. Again, when I have a lot of variables, this is why I label my diagram. It's a lot easier to pick out the variables. Then I have L times S, so I'm going to have a 15. S I said is 5, okay. Here we go. Plus, what else do we got here? L times W, so I got a 15 times W, which is 6. Okay, plug that in. Again, I'm making sure I plug it in right because I do not want to mess this up and have to do it again. And then an L times B, so I have a 15 times B, which is 8. There we go. All right, so let's widen this out so I can fit everything in there. There we go. All right. So again, gotta follow Bedmints, right? Say that all the time. Oops, got my cap locks on. All right, so 8 times 3, I know that's 24. 5 times 15, 75, I believe. Okay, 15 times 6. Should be another 15 on top of that one, so it should be 90. And then 15 times 8, I believe, is 120. All right, and then I add those together, which is no problem. So I get 24 plus 75 plus 90 plus 120. I get 309, and the units are centimeters. And again, because we're looking at how many squares will cover this object, it's centimeters squared. All right, now this diagram here lines up and looks exactly like this one here. All right, but this one, not so much. So again, a little harder to find your variables. All right, but again, I look here straight up. Well, I know that's going to be my height because that's along the bottom of my triangular prism here. And up we go. So that's my height there. And again, the height is based off of your base, which is this line here, which happens to also be that 16. So that would be 16 is my base. These are the side edges of that triangle. So 1's the W. So I'm going to say 12 is the W. And 10 is the S, which makes number 9 here the length. All right. Again, sometimes that's the hardest part, but again, I like to label my diagrams because now I'm going to use my formula here and I'm going to substitute in just like I did before. All right, so I have surface area is equal to, again, looking over my formula here, base times height. So my base was 16. I'm getting all this off my diagram now, times my height, which is 6. All right, plus length times S. So I got a 9 times a 10. 9 times 10. All right. And the next one is L times W. So length times 9 times 12. And lastly, making sure I get all the pieces in there, L times B. So I got a 9 times a 16. All right, now to do bedmouth, so I got to do all that multiplying. All right, so 16 times 6 is, I'm doing a calculator here, 96, plus 9 times 10, which I know is 90, plus 9 times 12, 108, and then 9 times 16, I don't know, get the calculator going on that one, we get 144, all right. And then again, the last step, adding them together, and I end up with 438 meters. And again, how many squares it takes to cover this object, which there's no chance I could wrap that present. That would be a mess. My family loves when I wrap presents. It looks funny. And there we go. So there's our surface area. So there's some triangular prisms. Again, the key here is this formula is not so bad. It's the substituting into it that's the hard part, is not mixing up your letters, not putting one in twice. Again, that's why I label my diagram and take my time going through it. All right, now there's prisms, which we did before. And the one prism we haven't done, the old surface area of the cylinder. So we got two parts to the formula here. We have a 2 pi r squared, and that is because pi r squared is the area of a circle, which we've done. We did that last unit. All right, but there's 2 of them. There's the top and a bottom, so that's why you get 2 pi r squared. And then 2 pi r h is the part that goes around the cylinder. All right, so in this formula, you need the radius and you need the height. So there's 2 things, right? The height and your radius. Actually, you need the radius twice for this formula. All right, so here we go. Chicken noodle soup, which we're all going to need soon. It's getting colder. All right, well, there's my r and there's my h. All right, so there's my formula I'm going to substitute into. So again, my surface area is equal to 2 pi r squared plus 2 pi rh. And again, I don't want to mess up my exponent, so we'll make sure we put it in there. There we go. All right, so I'm going to substitute in my values here. And so I've got my surface area is equal to 2 times 3.14. That's my pi. R, my radius. Well, right on the diagram, it tells us it's 4. And I got to square it. All right, so, and then I got 2 times the 3.14 times the r. Again, looking at my diagram, it's 4. My height is 7. Chicken noodle soup. All right, whoops. And now let's put the squared in there. And that's important because, again, bedmouth, I got to do the exponents first, right? Well, I do brackets first, but nothing's going on in these brackets, just numbers. All right, so surface area is equal to 2 times 3.14. 4 squared, 4 times 4, 16. All right, plus, again, I have all this stuff that I didn't do. I didn't have any exponents to do with it. So I'm just rewriting it out. There we go. All right, again, bedmouth, what's next up? Multiplying. So I'm going to do 2 multiplyings. I've got 2 times 3.14 times 16, and I also have these 4 numbers multiplied. So when I take 2 times 3.14 times 16, I get 100.48, right? Plus, I got to do this other part over here, bedmouth. I multiply those 4 numbers, and I get 175.84. All right. Now, the final part is now I can combine those 2 numbers, and I get 276.32. Again, notice I'm going to 2 decimal places all the time. The units are centimeters. And again, we're looking at how many squares it would take to cover this can of soup. There we go. So again, that formula is a lot more involved because you get 2 parts to it. You got to really make sure you follow bedmouth. All right, and substitute in correctly. All right, so every time I do an example, first example, it's a straightforward one, so there's got to be a twist in this one. And here we go. Find the surface area of the following cylinder. Anybody know what the twist is? Always have the twist.
It gives you the diameter, not the radius.
You got it. You got it. So the radius is half of our diameter. Diameter here is 16, because see that line goes all the way across. So we have an 8. All right, so I can substitute it in my formula, same one as before. 2 pi r squared plus 2 pi rh. All right, so my surface area is equal to 2 pi r squared. So 2 times 3.14 r squared. Our radius we just saw is 8. All right, I'll square that here in a second. So then we got 2 times pi. I'm just looking at my formula here. 2 times pi, 3.14. R again is 8. And my h, which is 12. Oh, and again, in our formula, that is squared. So we get 2 pi r squared plus 2 pi rh. All right. Now it's all about the bedness, right? So I got to do the exponent just like I did last time. So we had surface area is equal to 2 times 3.14 times 8 squared. 8 times 8, 4. All right, again, I'm just going to rewrite this part here. 2 times 3.14. There's our pi times r times the h. All right, so I got to do multiplying first or after now. It's the next step, right? So I take, I got 3 numbers here I got to multiply, and then 4 numbers here multiply. All right, so 2 times 3.14 times 64. And I'm getting 401. 0.92, going to 2 decimal places. All right, plus then I got these 4 numbers, 2 times 3.14, 6.28 times 8 times 12. And I'm getting 602.88. So it looks like my answer's going to be over 1,000 here. And so the last step, doing the addition, which I get 1,004.8. Yeah, 0.8. All right. And again, our units, meters. And we're looking at how many squares it would take to cover that object. And there we go. So again, same steps we've been doing. Anytime I can convert a fraction to a decimal, I do. Anytime I can sub in pi, I do. But again, once you substitute in, you have to follow bedness. And again, the key for me to make sure that I don't mess up the substitution is I label my diagrams.